In this video, we're going to learn how to identify the different types of chemical reactions, of which there are 5 that you should know. Synthesis, decomposition, single replacement, double replacement, and combustion reactions. So let's start with synthesis. In a synthesis, think putting together. So here's an example. We have magnesium and oxygen forming magnesium oxide. Notice that we have 2 elements, and 2 elements yielding 1 product that's a compound. And I'll just note that this is 1 product, just as product. There we go. Just as here below, we also have 1 product. In this case, we have 2 smaller compounds, and I'll point that out. Small, my word, my stylus is so laggy. But these are small compounds, and we have a large compound. We know it's large because this really is the sum of the 2 starting materials. So in general, with synthesis reactions, look for 1 product, look for smaller materials, elements, or small compounds yielding 1 larger substance. Next, we have decomposition, which is the exact opposite of a synthesis. Notice we have 1 reactant, and that's all you need. This is water decomposing into the elements from which it was made. And also it's possible for you to have a larger compound decompose into a smaller compound. A very common reaction is that chlorates will decompose to chlorides and oxygen, just releasing the oxygen from the chlorate. So that's decomposition. With single replacement reactions, we have an element. So I'm just going to label this as an element E plus a compound C yields a new compound plus a new element. So what's actually happening here is the magnesium is replacing the hydrogen. And it's important to note here that the stoichiometry is going to be that there are 2 hydrogens for every 1 magnesium. And that is indicated in the balanced chemical reaction, or balanced chemical equation. It's possible for metals to replace other metals. Notice that, well, I suppose in this case, the hydrogen is not a metal, but it's acting like a metal in the sense that it will be the more positive side of HCl. In acids, the H's act as though they're positive 1. But the magnesium replaces the hydrogen. It does not replace the chlorine. Always go for a metal replacing a metal or hydrogen. Similarly, we can have KBr, which is our compound, and our element Cl2 forming KCl, a new compound, and Br2, a new element. Notice it is the non-metal bromide that is being replaced by the non-metal chlorine. So it goes like that. And the potassium just changes what its partner is. It started with the bromide and ends up with the chloride. So that's single replacement. Look for element and compound on each side, and you should think, oh, this is going to be a single replacement reaction. With a double replacement reaction, this is a compound, a compound, a compound, and a compound. You will have 4 different compounds, and you just get a changing of partners. So the silver and the sodium swap, you could say. The sodium ends up with the nitrate, and the silver ends up with the chloride. So if I just move the sodium over to be next to the nitrate, and I move the silver to be next to the chloride, I get the products right here. And then finally, we have HBr and LiOH yielding LiBr and H2O. Note here, the hydrogen and the lithium change spots, and really this H2O is HOH when you think about it, like the H going next to the OH. But when you see HOH, you really should be thinking H2O. So maybe it's best to write it as H2O. Just to point something out, we will learn at a later time that not every potential single replacement reaction will happen. For example, you would not get hydrogen to react with magnesium chloride to produce HCl and Mg. Um, you would have to couple that with an extremely favorable reaction. The reverse of this would essentially not happen at all. The reverse of this reaction also essentially would not happen. At a later time, we're going to get into the activity series, which would explain why. Additionally, this reaction will occur in the forward direction. It will not occur in the reverse direction. And in truth, the starting materials are not that there's that there's sodium chloride sticking together and silver nitrate sticking together. It's actually that there are solutions of dissolved ions where there are silver ions, there are nitrate ions, there are sodium ions, and there are chloride ions. And the only thing that's happening is that the silver chloride comes out sticking together as a solid. But that is something that we will cover further in what is called net ionic equations, where we're taking a look at the compounds that are reacting and forming and seeing, wait, what is truly happening in the reaction? So that will be in a later video. But for now, we have these four reactions: the synthesis, the decomposition, the single, and the double replacement. And the fifth type of reaction is called combustion, which is very easy to spot because all we need is carbon dioxide and water as products and oxygen as a reactant. Always, when we have these three, the reactant oxygen and the products carbon dioxide and water, always when we have those three, we get a combustion reaction. So these indicate combustion. I will point out that what varies is the fuel that is burning. Combustion. What varies is the fuel that is burning. In this case, it's CH4, that's methane. If you have natural gas at home that's used to heat your house or your stove, that's CH4. C3H8 is propane, which is commonly used with grills. C4H10 is butane, which is common with lighters, et cetera, et cetera. CaH18 is octane, which is in gasoline. And that's really the variation that you'll see with combustion reactions, is what the fuel is. Also, it's possible for the fuel to be something that isn't just hydrogen and carbon. For example, a C2H5OH, which could be ethanol, which you may be aware that that's used as an additive in fuels, among other things. It can burn, and you'll have a case where you have the fuel still burning in atmospheric oxygen, still forming a CO2 and H2O. So again, just really look for the reactant of oxygen and the two products of carbon dioxide and water, and you'll know that you have a combustion reaction. Hope this video has been helpful. Let me know if you have any questions or comments in the comment section. Thank you.